Today we're going to talk about absolute value a little bit more. So those V-shaped graphs that you've been seeing all week, we're going to get a little bit more into the equations that make the graphs. So basically, absolute value by definition is the distance a number is from zero on a number line. So in other words, it's just going to be like a positive number. So like if you have a number line and you have zero in the middle, then you have, say, -4 on one side and +4 on the other. Then the distance that either one of these is from 0 is going to be 4. So in other words, if you have the absolute value of a negative number, like -4, then the distance that it is from 0, this space, it's just going to be the positive version of that number. Or if you have a number that is already positive, the distance it is from 0 is just going to be itself. So it's going to make negative numbers become positive, and it's going to leave positive numbers alone, and they're going to stay the same. So what we're going to work on today is actually solving absolute value equations. So like solving for x in these equations. So in each of these, you'll get something in the absolute value bracket, and it'll be equal to something on the other side. So there's going to be a couple of different ways to solve them, and whenever you're solving them out by hand, what you have to do is you have to break it down into two different cases. So the first case is whatever was inside this absolute value bracket, the 3x, it was already positive. And so whenever you bring the 3x outside of the absolute value, it's going to stay positive. The other case is that the 3x that was inside the absolute value was negative, but then when you apply the absolute value to it, it became positive. So you have to break it down into the positive case and the negative case. So with the positive case, the way that you're going to go about solving these is the first thing you're going to do is just completely get rid of the absolute value brackets. And then you're just going to solve it like a normal equation. So we had the absolute value of 3x equals 6. And then you're just going to get rid of those brackets completely, and you would have 3x equals 6. And then whenever you're solving for that, you would just divide by 3 on both sides and get x equals 2 as your answer. On the other side, the negative case, basically to solve these, you're going to start by replacing the brackets with parentheses. And then you're going to put a negative in front of the parentheses. Okay. Sorry, my pen's not wanting to write. Put a negative in front. And then you're just going to solve. So in this case, we started with, again, the absolute value of 3x equals 6. So then you just get rid of those brackets and you put parentheses in their place and then put a negative out front. And then in the next step, you're going to distribute that negative. In this case, the only thing that you had to distribute the negative to was the 3x. So it'd still just be negative 3x. And then whenever you divide by -3, you get x equals -2. So for most absolute value equations, there are two solutions. There is going to be something called an extraneous solution, which we're going to talk about in a minute. But let's go ahead and do a couple more examples. Okay, so our first problem is the absolute value of 2x equals 7. So I'm going to start with the positive case. And all I'm going to do is just get rid of the absolute value brackets and have 2x equals 7. And then I'm going to divide by 2 on both sides and have x equals 3.5. And that's going to be one of my solutions. And then I need to do the negative case. So I have the absolute value of 2x equals 7. I get rid of those brackets and replace them with parentheses, and I just throw a negative in front. And then I'm going to have it equal to 7. So then if I distribute that negative, just like in the last one, all I have to distribute it to is that 2x. So I would have negative 2x equals 7, and then I would divide by negative 2. So you would have x equals negative 3.5. So those would be your two solutions on this problem. So for all of the last problems, we just got a number and then the negative version of that number. So this is an example where you're going to get something just a little bit different. So we're going to start with the positive case. And with the positive case, I'm just going to get rid of the absolute value brackets. So I would have s plus 12 equals 15. And then to solve that, I would subtract 12 on both sides. So I would have s equals 3. So that's my positive answer. And then we're going to do the negative case. So I start with the absolute value of s plus 12 equals 15. And then I get rid of the brackets and replace it with parentheses and throw a negative out front and put it equal to 15. So then I need to distribute this negative, and in this case, it's going to be negative s minus 12 equals, and I put a negative there, I'm not sure why, but it would equal positive 15. I didn't mean to change that 15 in that last step there. And so then I'm going to add 12 to both sides, and I would have negative s equals 27. And then to make that negative s positive, I'm just going to divide by a negative 1. So I would have s equals negative 27. So then in this case, you have s equals 3 and s equals negative 27. So you don't have the exact same number and like the positive and negative value of it. So then, like I said, we were going to come back to checking for extraneous solutions. So first of all, I just want to make a note of what that is. And what an extraneous solution is basically whenever you solve it out, it works, but then if you plug the number back in, it's not an actual solution. So a solution found by solving that does not actually exist. So there are a couple of ways to figure out if a solution is extraneous or not. And the first way is just to plug the numbers that you get back into the original problem. So our original problem in this was the absolute value of s plus 12 equals 15. So what I'm going to do is I'm going to plug both of these numbers back in. So the first one that I got was 3 plus 12, absolute value equals 15. And then I'm going to actually do 3 plus 12 is 15. The absolute value of 15 is 15. And that works out. So we know that that's an actual solution. And then we need to do the same thing for the negative case. So s plus 12, absolute value equals 15. And so then I'm going to plug in the negative 27 for my s. And then plus 12, absolute value equals 15. Negative 27 plus 12 is going to give you negative 15. You're going to put that in the absolute value. And then the absolute value of negative 15 is 15. So 15 equals 15, and that is also a check. So that solution also works. So neither of these are extraneous solutions, but that is going to be one way that you check for them. And the other way to check for extraneous solutions or to double check and make sure that your answers are correct is going to be by graphing. So I pulled up Desmos, and essentially the way that you're going to want to graph these is you're going to use the equal sign as like a barrier, and you're going to put what is on one side of the equal sign as one equation and what's on the other side of the equal sign as another equation. So I need for one equation to be y equals the absolute value of s plus 12, and the other equation to be y equals 15. So I'm going to come to Desmos, and, well, let me type y equals. I have the absolute value, and then instead of s, I'm just going to type x. It's the same thing. So I have the absolute value of x plus 12. And then in my second equation, I need y equals 15. And then as you can tell, there's not really anything I can see on the graph right now. But on Desmos, you can just hit this little minus button to zoom out until you can see something. And then your answers are going to be at these intersections. And so you're going to use the x values because you're trying to solve for x. So if you look right here, you have one x where x equals negative 27 and one where x equals 3. And if we come back over here, we got x equals 3 and x equals negative 27. So that's another way to double check and make sure your answers are correct. Or if you wanted to just start by graphing and finding the x values that way, that would be another method of solving. All right, so we're going to start on another example, and this one's a little bit different just because instead of just having a number over here on this right-hand side, there's another x over there. So we're still going to start with the positive case, and we're going to do the positive and negative. So for the positive case, I'm just going to get rid of the brackets and have 6x plus 7 equals 5x plus 2. And so then I would solve it just like a normal equation. So I'm going to subtract the 5x to the other side and get x plus 7 equals 2. And then I'm going to subtract my 7. So I would get x equals negative 5. And that would be my positive case answer. So then I'm going to come over here and do my negative case. So I'm going to replace my absolute value brackets with parentheses and have 6x plus 7, and I'm going to throw that negative sign out front, and then that's equal to 5x plus 2. So then I'm going to distribute my negative, and I would have a negative 6x minus 7 equals 5x plus 2. And I'm going to start solving from there. So first I'm going to subtract my 5x, and in this case, I'm going to have negative 11x. And then I have minus 7 equals 2. And I'm going to add my 7 back. And I would get negative 11x equals 9. And then divide by negative 11. And x is going to equal negative 9/11. So these are my two possible answers. And we don't know currently if one of them may be extraneous. So to find that out, we're going to start plugging the numbers back into the original equation. So I'm going to start with the negative 5. My original is the absolute value of 6x plus 7 equals 5x plus 2. And so I'm going to plug in negative 5 for x. So I would have the absolute value of 6 times negative 5 plus 7 equals 5 times negative 5 plus 2. So then 6 times negative 5 is going to give us negative 30. And we're going to have plus 7. And then that would be equal to 5 times negative 5 is going to be negative 25 plus 2 is going to give us negative 23. And so then negative 30 plus 7 is going to be negative 23 as well. But that's going to be inside the absolute value. So when you take the absolute value of negative 23, you're going to get positive 23. And then positive 23 does not equal negative 23. So this right here is going to make this answer extraneous. So that means it's not an actual solution. So then we have to do the same thing with negative 9/11, which is going to be a little bit longer because of that fraction, but that's okay. So we're going to do 6 times negative 9/11 plus 7. And then that is going to equal 5 times negative 9/11 plus 2. And so on the left side, 6 times negative 9/11, we're going to do the 6 times negative 9 first. And 6 times negative 9 is going to be negative 53. So we're going to have negative 53/11 plus 7 equals 5 times negative 9/11 is going to be negative 45/11. And then plus 2. And you guys can use a calculator to work out some of these fractions. That is totally fine. So then we're going to do negative 53/11 plus 7. So negative 53/11 plus 7 is going to give us 24/11. And that's inside the absolute value. And then we're going to do negative 45/11 plus 2, which is going to give us negative 23/11. And I think I just realized a mistake that I made further up. That negative 53 was actually supposed to be a negative 54. So that's going to change it slightly. The inside right here should have been 23/11 as well. So that is my fault. So then we're going to have the absolute value of 23/11, which is just going to be 23/11. And then that would be equal to negative 23/11, which also does not work. So in this one as well, because these two sides are not equal, that negative 9/11 is also going to be extraneous. So that's why it's important to go back and check your answers. And then I know that in this one, it can be a little bit tricky. As you saw, even I messed up a little bit right there. So then this case is where it can be a little bit trickier. So what my suggestion would be is to go graph these in Desmos, like I was talking about earlier. Just have y equals the absolute value of 6x plus 7 on one side, and y equals the absolute, or not the absolute value, but just y equals 5x plus 2 on the other side. So we're going to go graph those. Okay, so I came over to Desmos, and on one side, I had y equals the absolute value of 6x plus 7. And then on the other side, I had y equals 5x plus 2. And so then you're going to look right here, and you're looking for an intersection between the two. And you can tell this v part of the absolute value and this line, they don't intersect anywhere immediately right there. And so then if I start scrolling up, you can tell that they only get further apart. So since there's no intersection between those either, that's also going to be another indication that neither of these solutions over here are going to work. And so in that case where none of the solutions work, you're actually going to get that there is no solution, and that would be your answer. So again, if you just want to graph it and look at that and see that there are no intersections, that would be another way to do this problem. And then this is the last problem that I want to go over. This one is different because it has stuff outside of the absolute value part. So anytime that there's something on the left-hand side other than just the absolute value, you're going to want to get rid of that first. So we're going to need to move that to the other side. So we're going to start by subtracting 6 from both sides. And then we're going to have 5 times the absolute value of x plus 1 is going to equal 15. And then we need to get rid of the 5. So I'm going to divide by 5 on both sides, and I'm going to get x plus 1 in the absolute value equals 3. And so then at that point, this is where you want to break it into the positive case and the negative case, because now we have just the absolute value by itself on that left-hand side. So the positive case is just going to be x plus 1 equals 3. All we do is get rid of the absolute value marks. And so then I'm going to subtract 1 on both sides and get x equals 2. And then the negative case is going to be a little bit different. You replace the absolute value from this step with parentheses, and then you're going to throw the negative out front, and it's going to equal 3. So then you're going to distribute that negative and get negative x minus 1 equals 3. And then you just want to add 1 to both sides, and you get negative x is going to equal 4. And then to get rid of that negative, you just divide by 1, or divide by negative 1 on both sides. And you're going to get x equals negative 4. So as of right now, you have that your solutions are x equals 2 and x equals negative 4. So in this one, instead of writing it all out again, which you can do if that's the method that you prefer, we're just going to go graph this on Desmos and see if there are intersections where x equals 2 and x equals negative 4. So I'm going to clear out what I had in Desmos. And on the left-hand side, I have 5 times the absolute value of x plus 1, and then plus 6 was on the outside. And on the right-hand side, I had y equals 21. And so then I just check these intersections, and I see that one of them is where x equals negative 4, and the other is where x equals 2. So that means that both of these solutions must have worked. So your solutions to this problem would be x equals 2 and x equals negative 4. So make sure on all of these that you're going back to check your work, whether you're doing it through this method where you're plugging all of the numbers back in and seeing if it works out, or if you're doing it through the method of graphing on Desmos like we did in this problem. But either way, just make sure that you're checking to make sure that none of your solutions are extraneous. And also double checking on Desmos is always a good call anyway, in case your algebra went wrong somewhere. You want to make sure that you have those correct x values. So that's pretty much it for solving absolute value equations. So you guys can go ahead and get started on your worksheet for it.